Okay, these next ones are a little bit more esoteric than I would want them to be. Um, I think we did that one, didn't we? Yeah, I've done up to 11, so we're going to go to 12. And again, this is very similar stuff as before. Um, it's just you fill up the compound angles as much as you can and simplify. So a lot of it is, monotonous, and I'm not sure if I'm going to do it all, if I'm going to try to get more chapters in. Um, oh, let's undo that. Well, let's try this. Ah, God damn it. Okay, gotta pause. So some of these are easier to do if you just do them one at a time. So sine pi plus that is going to be equal to the addition formula up above. So it's going to be sine pi. I got to get rid of 12 up above. Let's just, I'm having a lot of troubles today. There we go. We'll do that, and then we'll just undo things. There we go. And there we go. So first you solve that, and you quickly realize, okay, the sine of pi is 0. And the cos of pi is -1. So you get negative sine x out of this. And then when you do the other one, you're going to discover a lot of stuff cancels out. So then we're adding this to it, adding this to it. And this is a subtraction formula, so you have to use the subtraction up above. So subtraction is going to be sine pi times cos x minus cos pi times sine x. And again, sine pi is 0. So you're left with negative cos pi, and cos pi is -1, so that's going to be plus sine x. So we're left with sine x minus sine x plus sine x for the first part. For this part here, God, I hate that it defaults to the file. Okay, so this first part just becomes plus sine x minus sine x, which just becomes 0. And the second part is an addition for cos, so you have to use the cos addition. Which says cos x times cos pi over 3 minus sine x times sine pi over 3. And we quickly learn that pi over 3 for cos is a half. And we quickly learn that sine of pi over 3 is square root of 3 over 2. So you get square root of 3 over 2 times sine x and a half cos x. And then the second part is a subtraction. So that's important to remember. The second part is subtracting. We'll put this first part on the side. And the second part, you have to use the addition for sine, which is sine x times cos pi over 6 plus cos x times sine pi over 6. We quickly discover that pi over 6 for cos is square root of 2, square root of 3 over 2. And that sine of pi over 6 is a half, so you get half. And remember that this all has a negative in front of it, like in brackets, negative and brackets. That's how you should treat the negative anyway. Which means it becomes negative square root of 3 times sine x, negative half cos x. And notice that we get a half cos x minus square root. Oh, should that have been a plus? No, it should have been minus. And this minus translates into a minus and minus. So you end up with minus 2 square root of 3 over 2, which becomes minus square root of 3, times sine x. And the half cos x's cancel out. So that's what you should be left with, unless I did an arithmetic error. But I don't think I did. I mean, this is similar again. It would take me a hell of a long time to go through all the sine f, sine g, sine f minus sine g, sine cos. You can be sure there's going to be a lot of cancellations. And I don't even know if that's worth my time if I'm going to do more. Not creating a flow chart. I'm not using compound angular formulas in this last. Prove that this plus that is equal to that. I'm sure there'll be cancellations in terms of coat x and coat y. So a coat this will be simply the 1 over that. So a coat formula, if they want you to do it, will simply be a 1 over tan formula. If anything, you can flip these. But yeah, let's see if I can come up with a tan formula, actually, or a cotan formula. You can make a cotan in terms of tan. For instance, this would be the same as cotan, or 1 over tan. But to make it all cotangent, you'd have to put 1 over all of these. To add these, you'd have to cross multiply. And you'd get tan B plus tan A. I really hate that it doesn't stay on that screen. You get tan B plus tan A all over tan B times tan A. So that's the top fraction. And the bottom fraction would be, oh, those should be cotan, rather. Those should be all cotan. Oh, yeah, hang on. If you're going to do 1 over tan A, it becomes cotan A. So this simply becomes cotan A plus cotan B. Look, a lot of these are just working through the thing very slowly and meticulously. And I get that you want me to cover all the chapters, but there's no way I can cover all of these. And I hate rushing through each chapter because what's the point? So I'm not sure what I accomplished by skipping everything over and over again. It really doesn't. So I can't achieve your goal. There's just no way. I get that you want me to do all of 7. There's just no way. So I'm going to just start by doing 1 or 2 of them. So 2 sine C plus D. Try to keep that in mind that anything that is over 2 can also be written as this. So when you have this, it's really equal to this. And then when you multiply that by 2, and then the other one is this. Uh, and they're multiplying. this one up top is multiplying the one at the bottom. Yeah, I mean, the extension ones I'm just going to skip. Really, just work with your teacher. Let's go to the next chapter. So the next chapter is chapter 7.3, double angle formulas. So the double angle formula is when you have 2 times the angle instead of 1 plus the other. Keep in mind that sometimes 2 times the angle, like 45, is the same as 45 plus 45, and that's where they got it. So they converted double angle into sine one angle plus another angle, and they used the addition angle formula to come up with the double angle formula. And then they did the same with tan, and they came up with these double angle formulas. And they all come from the addition angle formulas. Now this one, you would use this one if you're given sine and you need to figure out cosine. You would use this one if you only want to work with cosine, and this one again you would work if you have cosine and sine. They're really the same formula, just the only difference is sine squared is replaced with 1 minus cos squared. And then the double tan formula. So those are the formulas you need. And we're going to put them up here. And then we're going to go work with the specific questions. Express each as a single trigonomic ratio. Oh my God, it's just endless. There's no way I can do 7 in this timeline. There's just no way. So I'm not gonna bother trying. It's just nonsense. Okay, we'll do those 2 like that. So we get 2 times sine 5x plus cos 5x Now, what's interesting about this is you have to think about in terms of what does this look like over here? Well, it looks like this, doesn't it? And then you'll notice, oh, okay, 5x is in here, and 5x is in here. So isn't 2 times 5x 10x? So doesn't this make sense? Let's take this formula, and we're going to say, okay, if I had sine 10x, what would that convert to? It would convert to 2 sine 5x times cos 5x. And lo and behold, that's what we have here. So that means the above is equal to sine 10x. This is equal to that. So it can be replaced. And a lot of these are very similar to the number 1 up above. If you look carefully, what does this one look like? It looks like this one, doesn't it? So that just means they're asking us to recognize backwards that this is indeed the same as cos 2 theta. This is the symbol that's in there. So that's the same thing. And then if you look at C, it's very similar. They're asking you to notice that this is the same as this. And they're saying, okay, well, if we're dealing with 3x as the angle, we can see that cos 2 times that is supposed to equal it. So we're really talking about, we're really talking about cos 6x, which is 2 times 3x. And then if we look at this, it's very similar to the tangent one, right? This is very similar to this one. But we notice the angle over here is 4x instead of theta, which means that we're talking about tan 8x, which is 2 times 4x. So tan 8x is going to be equal to this because it's the same as that. And this one, what does this one look like? Well, if you look carefully, it looks a lot like this. But this one has a 2 in front of it. This one has a 4. So it's probably going to be same as 2 times sine 2 theta, or the squiggle, because that will be equal to 2 times whatever this part is. So pretend you just have that. That is equal to the thing on the right, which means that 2 times that will be equal to 4, or 2 times the thing on the right, or 4. Therefore, 2 times 2 theta is equal to E. And then this one looks a lot like this one. But look at this, they have a half angle formula. This is an introduction to half angle formulas to show you that now you can go backwards. Because look, if this is true, the angle, this looks a lot like this. Except the angle in here is not theta, it's half a theta. And what's 2 times half a theta? Cos theta. So instead of cos 2 theta, we're really talking about cos theta is equal to this. And the reason they're bringing this up is now we can isolate a half angle formula. And we can say, okay, therefore, 2 cos squared, let's just do x over 2 instead of theta, is equal to cos x plus 1. Then I'm going to divide everything by 2. And then I'm going to square root it because this is squared, which means the cos of a half angle is equal to the square root of the cos of the full angle plus 1 divided by 2, which means if I wanted to find 12.5, or better yet, 22.5, 22.5 is a half of 45. So I can take the cos of 45, which is on our table, 1 over square root of 2 plus 1. So that gives me square root of 2 over square root of 2. Let's see, actually, the cos 45 becomes 1 over square root of 2 plus 1. 1 over square root of 2 plus 1 is the same as square root of 2 over square root of 2. So we're talking about 1 plus the square root of 2 over the square root of 2. All of it divided by 2, which is the same as multiplying by 1/2. Woo, where did I go there? So you're going to end up with 1 plus square root of 2 over 2 times square root of 2. So they're introducing you sort of a sneak preview of the half angle formula. What about this? It's the same sort of thing now. They're asking you to recognize what that looks like. Well, it looks like this. And what's twice 45? Sine of 90. Sine of 90, we already know, is equal to 1. So that means 2 times sine of 45, which we know is 1 over square root of 2, times cos 45, which is 1 over square root of 2. When I multiply 1 over square root of 2 times 1 over square root of 2, I get 1 over 2. When I multiply 2 times a half, I get 1. So it makes sense. And it's clear that this looks like this. So we're really talking about cos of 60. Is equal to that. And it just keeps going like that. What's this? It looks a lot like this. So that means we're talking about 2 times pi over 12, which is the cos of pi over 6. Well, we know what the cos of pi over 6 is on the left. The cos of pi over 6 is square root of 3 over 2. Which means you can, can you? Can't really, the way it is. I'm going to convert cos squared pi over 12 to 1 minus sine squared pi over 12 minus sine squared pi over 12, which is minus 2 sine pi over 12. You can now subtract 1. on both sides. Now you can divide by -2. This is all over 2. And when I can multiply by half, and I get that. And then this is pi over 12. So that means pi over 12 is equal to the square root of 3 minus 1 over 4. So again, that's sort of a way of figuring out half. Half, I don't know if that's what they want you to do in this one. I think they just want you to express it as a single trigonomic ratio. And then this last one looks like it's going to be, I get rid of this one, a tan. Actually, there's the last two. What does this one look like? It looks like this one, which means we're talking double 3 over 8, which is 6 pi over 8, which is 3 pi over 4. So we're talking about cos of 3 pi over 4 is equal to this. And then you could figure out what the sine of 3 over 8 pi is by isolating that. Because we have, if we look carefully, we know what cos of 3 pi over 4 is. It's on the left. Cos of 3 pi over 4 is the same as the negative cos of pi over 4. Anyway, you can figure out all those half ones if you wanted to, and there you go. I'm not going to do the other ones. I actually hate rushing through these chapters. Used double angle formulas to rewrite these. Okay. Sine of 4 pi, or 4 theta, let's call it 4x, is equal to 2 sine 2x times cos x. So cos of 3x, what's half of cos of 3x? It's 2, there's a whole bunch of ways I can do it. I can do 2 cos squared, 3x over 2, minus sine squared 3x over 2, or I can use the second one, 2 times cos squared, 3x over 2 minus 1, or I can use the third one, 1 minus 2 sine squared of 3x over 2. All I did was half the angle. That's all you're doing. Tan x, what's half of x? It's x over 2, so it's tan x over 2. All of that divided by 1 minus tan squared x over 2. What's cos 6 theta, 6x? It's equal to cos squared 3x minus sine squared 3x. And all variations. What's tan 5 pi, or 5x? It's 2 times tan of 5x over 2, all divided by 1 minus tan squared 5x over 2. Given this value, determine the value of 2 pi cos pi. Okay, so let's start with this. So this is between 90 degrees. Let's focus on this. We're talking a triangle where the hypotenuse is 5. And because the cos of this angle is adjacent, it's 3, which means this other side is 4. Which means the sine of this value, which means we'll call it cos x, is equal to 3 over 5. But sine x is equal to 4 over 5, and tan is equal to 4 over 3. So now you have the 4 values. And when you have those 4 values, let's put them on the side. You can work out all the other values. I'm just going to which means if I want to figure out sine of 2 pi, or sine of 2x, it's 2 times sine of x times cos of x, but they've given us sine of x. We figured out sine of x is 2 times 4 over 5. and 2 times 3 over 5. If we do 2 times 8 times 3, we get 24 over 25. And so that's what sine x is equal to, sine 2x. And then you do the same for the other ones. Cos of 2x, you can use either one. We're just going to use the simplest one, 1 minus 2 times sine squared x. Well, we know sine x is 4 over 5, so we're going to square it, which is 16 over 25. Multiply that by 2, minus 2, so we get minus 32. And we're going to put this over 25. And so we get minus 7 over 25. And then tan 2x is going to be equal to 2 times tan x, which we know is 4 over 3, which means it's 8 over 3, all divided by 1 minus tan squared x, which is 4 over 3, and that's going to be squared, 16 over 9. And this is 9 over 9. So 9 minus 16 is minus 7 over 9. So if we want to figure this fraction divided by this fraction, we have to multiply this by negative 9 over 7. So that's minus 36, minus 72 over 21. Oops. So that's what tan 2x is. Now they give us the sine for an angle that's between 3 pi, this is number 6, 3 pi over 2 and 2 pi, which is quadrant 4. They give us that sine is minus 12 over 13. Which means for sine, which is opposite, so that means the 12 over here is negative. And the 13 is over here, which means 169 minus 144, 25. It means this is 5. And it's positive because we're in quadrant 4, which means the sine of this one, we'll just leave it at sine, is, oh, I've skipped 5, it doesn't matter. Sine is equal to minus 12 over 13. Cos is equal to 5 over 13, which is why it's positive. And tan is equal to minus 12 over 13. And you just put those on the side. Yeah, we'll leave them there. Or you can shrink them, actually. There we go. Which means if I'm going to figure out the double angle formula for number 6 of sine 2 theta, or 2x, it's 2 times sine x times cos x, and as you can see, you just replace things over and over again. Sine x we've determined is minus 12 over 13. And cos x we've determined is 5 over 13. So we're talking about minus 60 over 169. A 2, is it 2 times that now? Yeah, it's 2 times that, so it's 1 minus 120. And I don't know if that's divisible. This is divisible by 3, and this is divisible by 3, 5. No, it's not. So just ignore that. And then, so we're on number 6. I'll go back to 5. If we're going to do cos of 2x, we're going to use the easiest one, minus 2 times sine squared. Well, sine we've determined is minus 12 over 13. Squared, it's 144 over 169. Times 2, it's 288. Minus 288. And then so you get 169 over 169. Minus 288 over 169. 170. So 30. 88 plus 30. It's 118, 119. Negative 119 over 169. And you just keep doing all that. 2 theta is going to be equal to 2x is going to be equal to 2 times x, which is minus 12 over 13. So you're talking about minus 24. So it's the same thing over again. Minus 24 over 13, all divided by 1 minus squared, which is 144 over 169. 169, 1 minus 144 is 25 over 69. And then you just have to multiply by the flip. Something like that. And I'll just let you do the math on that. Going back to 5, if we take our triangle here, this is in quadrant 2. We can see that the hypotenuse is 24. Oh, sorry, this is, they give us the tan. So the opposite, 24 over minus 7, which means this is 7 squared plus 24 squared, square rooted. $25. Which means the cos or sine x is equal to 24 over 25. Cos x is equal to minus 7 over 25. And tan x is given. So, oh, they gave it as minus. I got them all mixed up. And I'm on the wrong side. So this is going to be positive 7. And this is going to be minus 24. So that means this is actually sine. And this is actually cos and negative. Which makes the tan what they gave us. Put all those to the side. And then you just fill in the formulas again. And for this last one, they give us cos, and they're giving it in quadrant 3, which is over here. And obviously we're talking about minus 4 and minus 5. Sorry. That's adjacent, minus 4 over 5, which means that's minus 3. Which means the 3 values for this triangle, sine is equal to minus 3 over 5. Cos is equal to minus 4 over 5. Tan is equal to 3 over 4. And then you just use those in the formulas.